Okay, so today we're going to look a little bit more at factors and zeros of polynomials. So a quick little refresher. When you go to factor a polynomial, you're trying to figure out what multiplies together to get your original. So quadratics, we've done a ton of those, something like that. We're going to look at higher degree polynomials, and you can tell it's a factor if when you divide it, you get your remainder as 0, so it divides in evenly. So to check and see if x minus 1 is a factor of each of these, we're going to divide them by x minus 1. So synthetic division means you'll have to use your value that makes your factor equal to 0, 1 on the outside, and then just run through and do your division, which you guys are good at by now. So we'll divide and see whether or not x minus 1 divides in evenly. It does not. We got a remainder of 0 when we, or a remainder of 7, sorry, when we divided. So f of 1 gets us 7, not 0, which means that x minus 1 is not a factor of that original polynomial. Let's try this one. So again, checking to see if that factor of x minus 1 actually is a factor of this polynomial. Divide by it. Got a big synthetic division this time because it was degree 5, but run through. This time, when you divide, you don't get a remainder, or you get a remainder of 0. So that means that 1 is a 0, and x minus 1 is going to be a factor. We could use what we've done before and rewrite my original polynomial in its new form. Sorry, it got messed up on my powers trying to write and talk at the same time. But I could rewrite that original polynomial as those two things being multiplied together with no remainder, which meant that x minus 1 is a factor of my polynomial. So yes, it's a factor if it divides in evenly or you get a remainder of 0, however you want to think about it. So we're going to use that to factor some higher degree polynomials. So we're going to take this cubic, which we don't know how to factor right now. We could try grouping, but it wouldn't get us anywhere. We know that -3 is a 0, so that means that x plus 3 is going to be one of our factors. Let's divide by that and rewrite it as something with a factor of x plus 3. So divide, you end up with 6x squared plus x minus 1. So that original polynomial, we factored it into x plus 3 times that quadratic factor we just got. We can even factor it further. If we're factoring it into linear factors like the directions say, that means they need to be factors of x to the first power. So we could do a little guessing and checking. Factor that 6x squared. That's 3x and 2x. 3x minus 1, 2x plus 1. So the original polynomial is equal to those three linear factors being multiplied together. Sometimes the directions are a little bit different. Instead of being supposed to factor, on this one we're supposed to find all the other zeros. So factors, hey, means hey, factor it, and then you're done. Find all the zeros means figure out what makes it equal to 0. So we're going to go ahead and, since we know 3 is a 0, divide by the factor of x minus 3. And then hopefully we should get something that we can either factor and find the zeros of, or set equal to 0 and use a different method to find the zeros of. So divided by x minus 3 means I can rewrite my original polynomial as x squared plus 2x plus 2 times that x minus 3. Unlike the previous one, we don't get something that factors. So to figure out what makes it equal to 0, instead of just factoring and setting each factor equal to 0, we're going to have to use one of our other methods. So we could do quadratic formula, completing the square. You know what? I'm actually kind of feeling some completing the square. So I'm going to set that equal to 0 and solve for my zeros. Okay, so I can make that, subtract my 2 over, add 1 to both sides, x plus 1 squared, take the square root, plus or minus I, and then subtract 1, I end up with zeros of negative 1 plus or minus I. So my three zeros are negative 1 plus I, negative 1 minus I, and 3 that I had originally. So we're going to talk a little bit more about those complex numbered zeros. Actually, just like that one, complex numbered zeros always come in pairs. If one is a 0, then its conjugate is also going to be a 0 as well. So say, for example, that you know that 2 minus 3i is a 0. 2 plus 3i, its conjugate, is going to be a 0 as well. So if you have one complex number 0, you kind of get another 0 for free. But I know dividing by complex numbers is your favorite, so let's take one where we have a complex numbered 0 and find the rest of the zeros. Again, to use some synthetic division, we're going to divide by x minus the quantity 2 minus I. So putting our 0 out there and doing some synthetic division with some complex numbers. It's just a little bit more work because you have to multiply that negative 5 minus I back together times your 2 minus I. Try and do it without rewriting it all. See if I can not screw it up. Okay, so you get 6 plus 3i, multiply that back. You end up with just, positive 15. So it divides unevenly. So I've got now a quadratic polynomial with some really ugly complex number coefficients. So I'm not going to rewrite it as like an in-between step because it's like 1x squared and then a negative 5ix or minus negative 5 minus ix plus 6 plus 3i is my polynomial at the moment. Let's just go ahead and take that and divide again. So since it's not something that is easy to work with or factor yet, let's divide by our other 0 that we know from the complex conjugates zeros theorem, whatever that's called. So if you divide by 2 plus I, it comes out all nicely, and you just get a result of x minus 3. So it was x to the third, I divided once, it became x squared, divided another time. My final resulting factor I got is just x minus 3. So if I write it all in its factored version, it's going to look like that, which means that my three zeros are 2 plus I, 2 minus I, and just 3. So complex zeros, if you have one, divide by it, see what you get, divide by your other one, see where you can go from there. On all those, you were given a 0 to start with or a factor. If you don't have a 0 or a factor to start from, you're just gonna have to do some guessing. So you don't just plug in random numbers, though. There is some method to what possibly could be a 0. So it's going to be anything that, say you have a cubic polynomial like this, anything that is the form where it's factors of your constant, so in this case factors of 3, divided by factors of your highest degree term, which would be 2. If you take all possible combinations of those, which they call your constant and your leading coefficient, P and Q, if you actually read this theorem. If we do all combos of factors of 3 divided by factors of 2, that's every value that could possibly make our polynomial equal to 0. Which is good, because otherwise there's like an infinite number of possibilities. So thank goodness we can at least narrow it down to what might give us 0 as our output when we plug it in. So if you do like all those combinations, 1 divided by itself, 1 divided by 2, 3 divided by 1, 3 divided by 2, you end up with 8 possible zeros because they could be positive or negative. Then you would just have to like try dividing by them or plugging them in and guess to see which ones really are the zeros. So let's do one. Say we've got this degree 4 polynomial. We're going to figure out all of its factors and zeros. So to start with, let's list out what possibly could be zeros. Factors of 2 divided by factors of 6. which if I list them all out, factors of 2 are just 1 and 2. Factors of 6 would be 1, 2, 3, and 6. All positive or negative options are possible. 1 divided by all those gives us those as our possible zeros. 2 divided by everything. You get some repeats, like 2 divided by 2 is 1. We already have it, so we'll skip it. Then we've got 2/3. So there's all of the possible values that could make this polynomial equal to 0. Now we're just going to kind of have to guess which ones we're feeling lucky about and divide to see if they truly are zeros. So I'm going to try 1. So let me write out my coefficients here. We'll just see if it's going to have a factor of x minus 1. So if I divide by x minus 1, if this really is a factor, it should divide in evenly. Okay, let's see, it'd be 1. Multiply it back, gets you 1. Sometimes you can kind of try and think ahead if it's going to work or not. Yay! Divided in evenly. So 1 is a 0. So I've reduced this degree 4 polynomial to a cubic polynomial times 1 linear factor. Unfortunately, 6x cubed plus 13x squared plus x minus 2 isn't something that I can factor down all the way to linear factors yet. So we're going to have to guess again and divide by something else that we think might be a 0. So let's try 1/2. Okay, if we divide that 6x cubed that we got, I'm not going back to the original, I'm just sticking with my 6x cubed. If I divide it by my potential factor of x minus 1/2, though that's not going to go in evenly, because that'd be 9 times 1/2 would be 4.5, plus negative 2 is not a 0. So sometimes you guess and you're not right. Let's try negative 1/2 for our 0 instead. If it doesn't divide in evenly, try a different one until you figure out one that does. Okay, so negative 1/2 is going to be a 0. And now we're down to, after I've divided a couple times here, factors of x minus 1, x plus 1/2, and 6x squared plus 10x minus 4 that I just got. That is going to be something we can factor further. Let's see. Instead of guessing and checking, I should factor a 2 out of everything first. So let's do that. Okay, so factor out of 2, and then I could factor that further. 3x and 1x, and then, sorry, guessing and checking in my head. Okay, factors into that. So my final polynomial is going to have those 4 linear factors. So that's my factored version. All right, so I can take that factored version and figure out my zeros. So if you take and set that equal to 0 and see what makes every factor equal to 0, you will have all of your rational zeros. Since this was a degree 4 polynomial, you should end up with 4 zeros, and we will. 1/3, negative 2, 1, and negative 1/2 are your zeros. So it's kind of a long process, but hopefully you get the idea, and good luck with your homework assignment.